Good afternoon, heat and mass. So today we will be talking about 5 concepts of heat and mass transfer. Now these 5 concepts here are convection, conduction, evaporation, radiation, and water diffusion. Now for our demonstration today we will be focused on this ice cube. Now this ice cube is going to sit conveniently right here on our newspaper, or our holding plate, shall we say. Now, first of all, we will talk about the convection going on. So the air is moving around over top of this ice cube here, transferring heat into the ice cube and therefore trying to melt the ice cube. So our first equation here is convection. Now, convection is dependent on the temperature, your positioning, and the air moving around above it. So, continuing on with our equations while we let our ice cube sit for a little bit. Conduction is also going on at this time period because the desk and the paper, which the ice cube are on, are warmer than the frozen ice cube since they are at room temperature and it just came out of the freezer. Now, as the ice cube melts, there is a pool of water that will form around the ice cube, and this pool of water will then evaporate up into the air. This is based upon differences in concentration. So we will have A, or our ice cube, moving up into the air based upon its diffusivity in the air and different concentrations, because when there's a higher concentration gradient, it will diffuse faster versus as a lower, there will be less flux going on. Now, also, there are other means that the ice cube will melt by, these being radiation. So radiation in this equation shows how much light is incident upon the ice cube. Now, a good example of radiation in our everyday lives would be that of the sun. Now, since we are indoors, we can't have all the sun radiation beating on the ice cube. But if it were, we could use this equation and identify exactly how much of it is incident upon the ice cube. Now, our ice cube also will generate water, again, which we used when we were talking about evaporation before. Now, this pool of water around the ice cube will slowly start to diffuse and move into the medium around it. In this case, we're using a piece of newspaper. So our ice cube is diffusing into our newspaper, and it will be governed by fixed second law here. And this will say that as the concentration changes with time, it's all based upon the diffusion, and the ice cube in the pool of water will slowly spread out through the piece of paper. Now, if we look at our ice cube now, we can see it slowly starting to diffuse. So we have our ice cube here, which started initially in this area. There's just a little bit of water, as I can feel and you can see. Now, if I remove the ice cube, we can see how it has already started to diffuse into the newspaper. So you see this dark spot on the newspaper. This is via diffusion of the ice cube. So, and as you can see, like the ice cube just keeps dripping and dripping. So that is due to the convection of the air and conduction between the ice cube and my fingertips. So that sums up the 5 different concepts of heat and mass transfer that we can see every day in a common ice cube. So thank you very much for watching, and I hope you learned something.